Hi everybody, welcome back for yet another exciting online chemistry lesson. Today what we're going to be doing is continuing on with the hydrocarbon lesson that we started last time. We're going to be looking at some longer and more complex hydrocarbons and even venture a little bit out of the hydrocarbon organic molecule classification. So without further delay, let me get right into it here, bring up my PowerPoint. Okay, so I'm going to call this hydrocarbons lesson number 2, although like I said, towards the end we are going to look at some molecules that are not hydrocarbons. Just a refresher from last time, a hydrocarbon is simply a molecule like one of these two where they are made up of pure carbon and pure hydrogen. Anytime you have any other type of atom attached, it is no longer a hydrocarbon. All right. So last time, our last lesson, we focused on some smaller or shorter chain hydrocarbons. And the reason why is if the chain isn't very long, those hydrocarbons are a little bit easier to name, because what you're looking at here on this screen is two molecules that are very, very similar to one another. In fact, they are actually isomers of one another. They have the exact same molecular formula. They have the same number of carbons and hydrogens. However, their structures are different. See here how the double bond is between the two leftmost carbons in the chain, and then over here the double bond is in a different position. This gives these two molecules different properties as well as different names. This molecule over here is referred to as 1-pentene, whereas this molecule down below is referred to as 2-pentene. So I'm going to explain a little bit more about how we name molecules such as these and how we basically tell people where the double bond falls in the molecule's chain. So is it right here at the start, or is it somewhere in the middle? So important in this lesson is going to be the realization, and let me just back out of this for half a second, that some molecules, when you first look at them, they may appear to be different. Like if you look at these two molecules right here, you might think to yourself, oh yeah, those are definitely different. But they're actually the same, because all I have to do is rotate this molecule 180 degrees, maybe a little bit better than that, and you can see these molecules are identical to each other. So what we don't want to do is we don't want to come up with two different names for the same molecule, which would basically be based on its orientation in space. So a very pivotal skill with not only naming hydrocarbons, but any other organic molecule is what we call the numbering of the carbon chain. So basically, there's always going to be a carbon number 1, obviously. And the thing is, the carbon number 1 could be the leftmost carbon in the chain, or it could be the rightmost carbon in the chain. So that means we can number these carbon chains from left to right, which is what most people do naturally, or we could actually number them the opposite way, from right to left. So basically how that comes to be is when you look at a hydrocarbon or any other organic molecule, to figure out which carbon is carbon number 1, again, whether it's the left or rightmost carbon, what we want to do is figure out of those two carbons, which one is located closest to something referred to as a functional group, and I'll explain in a moment what that is, or which of those N carbons is closest to the double or triple bond. So if we look at these two molecules right here, if I was going to name the left one, I would start out its name like we learned last time. There's 5 carbons. So I would say the prefix for 5, and that's on table P, is pent. There's a double bond in the chain, so it's an alkene. Alkenes names end with ene, so this is pentene. Over here on this molecule on the right, I could do the same thing. There's 5 carbons, so I'd say it's pent. There's a double bond, pentene. But these molecules, if we look at them, they're actually not. They actually are the same, they are the same molecule. The one over here has just been rotated 180 degrees. So if I was going to number the carbon chain in both of these molecules, I'd say, okay, where is carbon number 1? In this case, over here on the left, the leftmost carbon is closer to the double bond than the rightmost carbon. So because the leftmost carbon is closer to the double bond in the chain, I'm going to call the leftmost carbon, in this case, carbon number 1. So that means I would number this chain from left to right. This is carbon 1, carbon 2, carbon 3, 4, 5. But over here on the right, if I look, actually the rightmost carbon is closest to the double bond in the chain. So that means the rightmost carbon is carbon number 1, and I would number this in order from right to left, so basically backwards. 1, 2, 3, 4, 5. What I'm going to get into in a minute is why we're doing this. This is going to help us tell people where the double bond is located in these molecules. In both of these, because they are the same molecules, they're just rotated, the double bond starts on carbon number 2. So the name of both of these molecules is actually 2-pentene. The 2 is how we tell people what carbon in the chain the double bond would start on. So if you're going to name a longer chain alkene or alkyne, you have to tell people where is that double or triple bond in the chain. Does it start on the first carbon in the chain, the second, the third? It's important because that determines what kind of properties that molecule would have. So if I was going to name this molecule over here to the right, I would start out like we learned last time. There's 4 carbons. The prefix for 4 is but. There's a double bond, which means it's an alkene. We will call this butene. In this case, I actually can number the carbon chain from left to right or right to left because both the leftmost and the rightmost carbon in the chain are equidistant from that double bond. I'll go left to right, but again, we could go the other way. In this case, it doesn't matter. This can be carbon 1, 2, 3, and 4. The double bond starts on carbon number 2 and connects it to carbon number 3. So I would name this molecule 2-butene, which would tell people that the double bond is mid-chain. It's starting on the second carbon in the chain. Over here on the right, I would start naming like we learned last time. I would count the carbons. There's 1, 2, 3, 4, 5, 6 carbons. According to table P, the prefix for 6 is hex. This time I see a triple bond, which means this is an alkyne. The names of alkynes end in "-ine". This is hexyne. In this case, I need to figure out where carbon number 1 is. Is it the leftmost or the rightmost carbon in the chain? It's going to be the rightmost carbon this time. This is going to be your carbon number 1. Why? This carbon all the way to the right is a heck of a lot closer to this triple bond than this carbon all the way over here to the left. So this chain I'm actually going to number backwards from right to left. This is carbon 2, 3, 4, 5, 6. Since the triple bond starts on carbon number 1 and connects it over to carbon number 2, I'm going to add a 1 to my name, 1-hexyne, which tells people the triple bond in this molecule is right on the end. It's on the first carbon in the chain. It's not mid-molecule. So to take it one step further, we're going to draw 2 representations of the molecule that's referred to as 2-pentyne. We would need to break this name down. The prefix pent tells me that there is 5 carbons. If you don't know that, look at table P. The suffix "-ine tells me that there is a triple bond somewhere in this molecule. The 2 tells me where that triple bond falls. It starts on carbon number 2. It does not mean there are 2 triple bonds, it's just telling me where to put it. So if I was going to draw this molecule, I would start by drawing 5 carbons. I would connect them with single bonds, except for carbon number 2. The 2 is telling me that's where the triple bond falls. I would single bond the rest of the carbons together, and then I would just make sure they all make 4 bonds. This carbon right here actually already has 4 bonds coming out of it, so it doesn't need any hydrogens. As does this carbon right here, also has 4 bonds coming out of it. So this last carbon here would just need 3 more bonds. To the additional bonds that I made, I would just attach my hydrogens. Now you could go ahead and use the general formula like we learned last time and actually figure out beforehand how many hydrogens you need to add. But what I'm telling you is if you just remember that carbon always makes 4 bonds, once you connect the carbons together in the chain, just make sure they all have 4 lines or 4 bonds coming out of them. only have about 5 minutes left in my recording, so I'm just going to show you very quickly. I did say to draw two representations of this molecule. You could have easily numbered the chain the other way. You could have gone from right to left, which means that this is carbon number 2, and this would connect to carbon number 3. So this would be like 1, 2, 3, 4, 5. So this is another representation of this molecule right here. And then I would just go ahead and add my hydrogens. I know this is sloppy, I'm sorry, but I'm just trying to show you, just make sure your carbons have 4 bonds coming out of them. So these are the same molecule, they're just rotated differently in space. All right, the last thing I'm going to talk about today is a different class of organic compound. This is not a hydrocarbon because it has other atoms bonded to the carbon chain. This is a class of molecules called a halide. Information about them is right here in table R. But basically, a halide is an organic molecule, a carbon chain, that has one of the halogens bonded to it somewhere, one or more halogens. So fluorine, chlorine, bromine, or iodine. There can be multiple halogens bonded to the chain. If that's the case, you're going to have to use some prefixes when naming. In here, there's 2 fluorines bonded to this carbon chain, 1, 2. So if I was going to name this in my name, I'd have to use the prefix di. I'm going to show you an example of naming in just a moment, so hang on tight. So when you go to name these, not only do you have to tell people where these halogens fall in the chain, are they on carbon 1, carbon 2, carbon 3, but you have to add actually an additional prefix to your hydrocarbon name. So the prefixes you would use would be chloro, fluoro, bromo, and iodo, depending on which halogen is bonded. So if I was going to name this, here is how I would proceed. I would start with the hydrocarbon name first and then add to it. There's 2 carbons. The prefix for 2 is F. Between my carbons, I only have a single bond. It's an alkane, so I'd say ethane. And then what I would do is look. I have 2 fluorines here, so I'm going to need to use the prefix fluoro. I'm just going to put it right at the front. But I have 2 fluorines, so I tell people that by using the prefix di. So far I have difluoro, 2 fluorines, ethane on a 2-carbon chain. I'm not quite done yet. In addition to this, I'm actually going to have to tell people where these fluorines are. In this case, they're on carbon 1 and carbon 2. It doesn't matter which way I number it, right to left, left to right. Still, there's 1 on each carbon. So I would say 1, 2. That tells me there's 2 fluorines, 1 on each different carbon, 1 on carbon 1, 1 on carbon 2. Difluoroethane is how I would name this molecule. So to name these last 2 to wrap it up, this one over here on the left, it only has 1 carbon. Take my word for it. The prefix for 1 is meth. You would say this is methane. So there's only single bonds in the diagram. I have 1 chlorine, so I'm just going to call this chloromethane. I don't need to add a number to this name because there's only 1 carbon, thus the chlorine can only be attached to that carbon. I don't need to tell people this is like 1 chloromethane. Over here, this last one, there's 3 carbons in the chain, so I would use the prefix prop, that means 3. There's single bonds between the carbons, so I would use the suffix ane. In this case, though, again, we have to figure out where carbon number 1 is. It's going to be the rightmost carbon in the chain because this carbon is closest to the chlorine. So basically, if you look at the leftmost carbon, it's furthest from those chlorines. This is carbon 1, carbon 2, carbon 3. So when I go to name this, I tell people that there are 2 chlorines in this molecule. So to propane, I'm going to add the prefix difluoro. You have to tell the people that there's 2 chlorines, and then give the position of them. They're on carbon 1 and 2. So the name of this molecule would be 1,2-dichloro. This says propane. 1,2-dichloropropane. All right, again, please feel free to email me with any questions, thoughts. Make sure you check out the summary sheet. I'm going to try to have a video meet next week to kind of check in with you all and see how you're doing on this. Other than that, this week, we'll video meet this week a little bit later to see how you're doing. Other than that, I hope you enjoy the rest of your day. Bye-bye.